All right, so 5.5 is basically we're finding rational roots. And remember, roots means that's the zeros, that's the solutions, that's the answers, whatever you want to call it. That we're finding out what x is. And again, rational means fractional, but again, fractional could also mean that it's the fraction is 6/1, so it's really just 6. So this is basically any kind of answer that could be a whole number or it could be a fraction, and these are the roots of the solutions that we've got going on here. Again, for keeping up with notes, this is for the second 9 weeks, number 5. If you keep up with the dates, today's the 23rd. Okay, now here's the biggest thing for this one. We've talked about yesterday. We did some synthetic division. We also went back and earlier we were talking about doing square root property and factoring and everything. Basically, for everything that's happening here, this is kind of what you want to do. That if you've got some equation that you're working on and factoring doesn't work, this is kind of your option for what you want to do. Because everything up to this point, factoring has been an option. We've done some square root property. We've done some other different things, but we've always been able to kind of fall back on factoring. This is kind of what you want to do when factoring doesn't work. That maybe the expression, if there's a sample problem that's on the board up there, that's 3x to the fourth minus 6x to the third minus 10x squared minus 2x plus 8. It's a big expression, so factoring is not going to be an option that's going to work there. So this is kind of what we do that if factoring doesn't work. So the very first thing that they're going to talk about is the rational root theorem. And that's really, I guess, the big focus for this section is that this is the main thing that we're kind of talking about off this part of it. And the rational root theorem, it gives you all the possible real rational roots. Again, when they're saying roots, we're talking about solution. These are the answers to the problem. So we're trying to find out what x equals. So these are all the parts that x could possibly equal for this thing of a polynomial equation. Now, in everything that we've done so far, x squared or anything like that, we always had some way we could solve it. We could do the quadratic formula. So this one, for the most part, is going to be us doing x to the third, x to the fourth, x to the fifth. So it's basically things that are too big that factoring doesn't work is really what it comes down to. Okay, and here's the whole big thing for the rational root theorem. They call it P over Q. And the P is basically this, and this is where, again, math people get to be kind of lazy, and this is kind of their shortcut for this part. This is the factors of the constant term. And then the Q is the factors of the leading term. Okay, so anytime you see I'm talking about P over Q, that's the short version, them saying you're finding all the factors of the constant term, and you're going to divide that by all the factors of the leading term. Just a lot shorter, quicker, faster, easier way if you just say P over Q. It's just kind of what we're going for. Okay, and then the best way to do this is just to show you a couple examples of what this is and how it works, and then we'll use that. Once you kind of see how it works, we're going to use that to kind of go to the second step on this one to get to the next thing that's here. So the directions will pretty much say something like this: use the rational root theorem to list all the possible roots. let's go x to the third plus 3x squared minus 10x plus 4 equal to 0. Okay, now in everything we've done, and we'll even try it on this one, and you don't have to write this down, you just kind of watch and see. So I'm going to do this in pencil because I'm going back and erase it. But in this case, if we were trying to solve this thing, there's 4 terms. We would try to do factor by grouping. So we put these 2 terms. Again, don't write this down because this is not going to work. So I'm going to tell you this one, that you just watch this one so you kind of see what's happening. If you do greatest common factor here, you could take out an x squared to make it x plus 3. There is no way you're going to be able to get an x plus 3 out of this. You got negative 10x plus 4. You can take out a negative 2. That's going to leave you with 5x minus 2. So you can see that these 2 things aren't the same, not even close. So factor by grouping is not going to work because that's what we've always kind of looked at. So basically, here's what we've got a problem. We've got this where factor by grouping doesn't work. So this is out. So we got to have a backup plan. All right, and our backup plan then is, okay, if factoring doesn't work, then the very first thing we're going to do is we're going to use the rational root theorem to go back and list all the possible roots. So if we do P over Q, well, there's our constant term. This is basically our P, and in that case, our Q would be the number that would be there. So that's basically that our P is 4 and our Q is 1. So it's the factors of 4 over the factors of 1. Okay, and purposely pick one that it's not too big because there's only a couple of ways you can get 4. You can either do 1 times 4. And now it is a positive 4, so you could do a positive times a positive, but you also could do a negative times a negative. So we got to kind of throw out both options on this one, that it could be positive 1 times positive 4. It also could be negative 1 times negative 4. So you have to kind of throw out the plus or minus there. And if you do 2 times 2, well, you don't have to put the 2 twice. You can just put it once because it could be positive 2 times positive 2, or it could be negative 2 times negative 2. All right, and then the factors of 1, well, same thing. It could be positive 1 times positive 1, or it could be negative times negative. So we're going to say that the factors of 1 is just 1. Okay, and then what they want you to do then is they want you to go back and take all these numbers that's on the top and divide it by the numbers that's on the bottom. But what happens when you divide something by 1? Nothing, right? I mean, it doesn't change anything. So for this one, if it tells you to list all the possible real rational roots, then it's just going to be 1, 2, and 4. All right. So when they ask you to go back and do that, that's what we're doing. Now, again, if it's over 1, it's kind of I won't say it's a trick question, but it's an easy question because if you divide everything by 1, it doesn't change anything. So it's just those numbers. Let's give you one here where the first number is something other than 1 because it does change it just a little bit. All right, so let's go with 2x to the 4th minus x plus 6 equals 0. All right, so the 6 is our p, and the q is our 2. So if we do p over q, that's the factors of 6 over the factors of 2. Okay. Now, you don't necessarily have to put the numbers in order, but usually it makes it a little bit easier. So if you do 1 times 6, you might want to leave a little bit of a gap there because in between that, we're also going to have to do 2 times 3. So you don't have to put them in order, but a lot of times you'll kind of see them in order because it just makes sense to kind of put the numbers in order. All right, and on the bottom, there's only one way to get 2, and that's 1 times 2. Okay, so here's what we're going to do. We're going to go back and take all these numbers, and we're going to divide everything by 1. We're going to pretend like that 2 wasn't here for just a minute. If you divide everything by 1, it doesn't really do anything. It's just 1, 2, 3, or 6. Okay, but then you've got to go back and divide. After you divided everything by 1, you kind of cover that part up. Now you got to go back and divide everything by 2. So it's 1 divided by 2, which would be a half. Then it's 2 divided by 2. Then it's 3 divided by 2. And then it's 6 divided by 2. All right, hopefully at that point you're kind of going, well, wait a minute, because 2 divided by 2 is just 1. So yeah, it is. So we can knock that one out. 6 divided by 2 is 3, so we can knock that one out. So if they ask you to list all the possibles for this one, so we're going to do 1, 2, 3, and 6. But then we're also going to put in 1/2 and then 3 over 2. All right, let's do one more of those, make sure everybody's feeling okay about that. And then we'll show you one other little thing we're going to do once we've got this set up. All right, so we'll go 3x to the 5th plus 2x squared minus 12 equals 0. All right, so if we go P over Q, our P is negative 12, and our Q is 3. Okay, now again, you don't have to write out the factors kind of like we were doing up here, but we're just kind of doing that to kind of make sure that we knew what was going on. So if we do P over Q, if we do 12, that's, again, you're going to kind of space this one out because there's a few more for 12. We've got 1 times 12. We can do 2 times 6. And we can also do 3 times 4. All right, on the bottom, there's only one way to get 3, and that's 1 times 3. All right, and again, if you divide everything by 1, it doesn't change anything. So you're just going to write down that same list of numbers that's here. Some people say, like, well, that seems like a waste of time. Well, just kind of holding on to it for a little bit. If you want to make some shortcuts to this one when you start doing these problems, you can, because it's always going to be the factors of this number. And then you got to kind of figure out what fractions numbers it's going to be. Now, we're not going to list all the fractions this time because we're just going to put the ones that we need. That if we start dividing everything by 3, we've got 1 divided by 3. Well, that's not on the list, so we'll put in 1/3. 2 divided by 3 is a fraction. It's not on the list, so we'll go ahead and put that. Okay, if we do 3 divided by 3, that's 1, so that one's already here, so we're not going to worry about that one. 4 divided by 3 is not on the list, so we'll put that on there. 6 divided by 3 is 2, so we've already got that one on the list, so we're not going to worry about that one. And then 12 divided by 3 is 4, so that's already on there, so we don't have to repeat it. So that would be our full list of all the possible answers we can go through. Okay, so if they tell you to use the rational root theorem to list all the possible roots, that's what you have to do. Now, what that is, again, this is basically saying that if we were going to solve, if we had to try to solve this equation, these are the possible answers that you would have to pick from. Because if we weren't able to do all this, we would just start randomly guessing and checking some numbers and see what happens. This is saying, all right, for this problem, we don't have to worry about checking 5 or 8 or 9 or 10 or 11 or any of those numbers. This one kind of starts narrowing down that these are the only choices. We don't have to worry about checking a half. We don't have to worry about checking 1/4 or 1/6 or 1/8. These are all the possible answers. These are the only answers it possibly could be. So we've gone from having just an unlimited amount of possible answers to check, and we're narrowing it down. So now we've got kind of a small list of numbers to go through and check and see what we're going to do with it. All right, now here's where we actually kind of do something with these numbers, because right now we've just got this list of numbers and people go, all right, well, what good does that do us? We've got a list of numbers. Great. Here's what we're going to do. Here's how we take this list of numbers and make this thing work. So to find the actual roots, again, when we think roots, think solutions. These are the answers. If you want to get the actual answers to this thing, the actual solutions, after listing all the possibles. All right, you're gonna do a couple of things. Number one, you're gonna check the possible solutions. Using synthetic division. All right, and people are like, well, what are we doing here? When you check synthetic division, you need the answers that have a remainder equal 0. So if the remainder equals 0, then it is a solution or a root. Okay, and that's what we yesterday when we were talking about doing synthetic division, that we said, if it equals 0, then it was a factor. Then if it was a factor, it was also a solution. So that's kind of where we're going with this thing today, is that we're going to do synthetic division, and as soon as we find one that equals 0, then we've got an answer that's going to work for this thing. Okay, now once we do that, we're going to do like a 2A and a 2B here, because we got kind of a couple options after this one. Once you have this solution, then what you're going to do is you're going to see if you can factor. And if you factor it, you're going to go ahead and solve it. So then see if you can factor and solve what was below the division bar. And more than likely, I'd say 75% of the time, maybe a little bit more, that once you get this first solution that you get here, if you take what's left over in synthetic division, the other parts that were in front of the 0 here, you can usually go back and factor that one to get some answers from there. Now, it may possibly be for 2B, we'll kind of say this one, that if you cannot factor it, then you keep doing synthetic division. So we'll say if factoring isn't possible, then you keep doing synthetic division. to find more solutions. Okay, so we're going to do synthetic division to see if we can find 1 equals 0. Eventually, you're going to find 1 because I remember we were doing this problem one year. And in a normal year, and again, this is not a normal year, but in a normal year, this is a part. If we do this, if we were splitting this thing up into 2 tests, we would do like a test on the everything we covered up through 5-4, and then 5-5, 5-6, 5-7. We would do that like as a group, a partner test. And so I was given a problem to them one year when we were doing some partners, and some people got to this. They were doing this part of it, and they were like, well, "We can't find any of these things that have a remainder equal 0." And I was like, "Well, then you're doing something wrong." I'm like, "There's an answer on this one. You have to find an answer when you're going through this thing." And so the people that were working together eventually started checking each other's work, and one of them looked at them and was like, "Hey, what are you doing?" They were like, "Was that not how you do synthetic division?" And they were like, "Well, no, you're doing it wrong." So then they had to go back and kind of catch up that one person was doing synthetic division wrong, and that was messing the whole thing up. That's why they couldn't get any answers on this one. So you've got to kind of know how to do synthetic division, because if you don't, then you're kind of stuck. You get lost in this thing. Okay, so here's what we're going to do. We'll do this as like a 2-part question. And some of these it may not ask you. Some questions it may just say solve it, and you may not do this, but we're going to do like a part A. We're going to say list all possible roots using the rational root theorem. So it's like part A, and then solve. So part A, we're going to list all the possible roots, and then part B, we're going to solve this thing. But you have to use A to kind of get you to part B. Now, again, sometimes they won't ask for this one. Sometimes they'll just give you an expression. They'll just say solve it. But even then, if it just says to solve it, you still kind of have to do both parts on this one. All right, so here we go. So example 1, we're going to do 2x to the third plus x squared minus 7x minus 6 equal to 0. All right. Now, one thing I would say is that when you're doing these, you still want to keep this factoring sheet that we did a little while back. Go ahead and keep this thing out, because we've got 4 terms. You'd go back and check and see if factor by grouping would work. For this problem, if you go back and check it, it's not going to work, because this one we could take out an x squared. This would leave us like 2x plus 1. This is not going to be 2x plus 1, because there's nothing you can factor out of this one. So factoring is not going to work on this part. So we're going to have to do the part A where we're listing all the possible rational roots. So in this case, we've got our P is at -6, and our Q is at 2. All right, so if we go P over Q, that is what, 1 times 6 or 2 times 3. And for Q, well, that's 1 times 2. All right, so again, we divide everything by 1. That doesn't really change the numbers here. So the possible roots are 1, 2, 3, and 6. But if we divide by 2, we're going to get a couple of fraction answers. It's not going to simplify. So we've got 1 divided by 2, so that would be a half. 2 divided by 2 is 1, so that one's already on the list. 3 divided by 2 is not on the list, so we put that one in. 6 divided by 2 is 3. That's already there, so we're good to go. So there's all the possible roots. All right, now here's where it comes down to the problem. And this is where, if we were doing a partner test, this is kind of where we'd go from here. From here, there's really not anything. It's just, and honestly, it's just guess and check. There's not really, here's the pattern to it. Most people don't like fractions. So I would say when you're doing these, don't worry about checking the fractions on this one. A lot of times with these problems, even the big number is not going to work. So most of the time, your answers that you're going to get, usually it's going to be in the smaller group of answers. But just so you kind of keep in a pattern, I would say you start with positive and negative 1, and then you check that one, and then you go to positive and negative 2, and if that doesn't work, then you go to positive and negative 3, and then you just kind of keep going from there. So you start with the smallest whole number, and then just kind of keep working your way up. Okay, so we're going to do a guess check. We're going to guess positive 1, and we're going to do synthetic division. So we're just going to do a guess and check with synthetic division. All right. Terms are in descending order, so we're good there. There's no powers of x that's missing, so we're good there. So if we start with positive 1, just do guess and check, it's going to be 2, positive 1, negative 7, negative 6. Okay, and for the few people that weren't here yesterday, this is going to be kind of a crash course version of synthetic division, but this is basically what we do here. All right, so all you do is you take out the coefficients from the equation that we've got here. So we've got 2x to the third, we've got a 1x squared, a negative 7x, and then a negative 6. So we put those numbers down. And then to kick this thing off and do synthetic division with this one, we're going to pull the first number down. And then after that, we're going to multiply 1 times 2, which is 2. And then whatever these two numbers are, you add or subtract depending on the sign. So it's 1 plus 2, which is 3. And then just keep repeating from there. So now we're going to do 1 times 3, which is 3. Negative 7 plus 3 is a negative 4. And we're going to do 1 times negative 4, which is negative 6. Put those two together, that's negative 10. And we're looking for an answer that gives us 0. That was not 0. So this one didn't work. All right, so if positive 1 doesn't work, then just through a process of elimination, let's go check out negative 1. All right, 2, positive 1, negative 7, negative 6. And basically same step, same problem. And again, this is why if you don't know how to do synthetic division, this is where you're going to kind of get stuck on this one, because you have to know how to do synthetic division. All right, we're going to do negative 1 times 2, which is negative 2. 1 minus 2 is negative 1. Negative times negative is a positive 1. Negative 7 plus 1 is a negative 6. And if we do a negative times negative, that is a positive 6. That's 0. And that's a big old yes. So that's our first solution right here. So x equals negative 1 is our first solution. All right, now here's where you kind of have two options. And some people would rather do this, some people would rather not. That if you wanted to, because once we've got this answer, what you could do is you could use these numbers that you've got left over here, the 2, the negative 1, and negative 6. And now you can keep on going and doing synthetic division with this one. You could keep, you could go back and try the 1 and the negative 1, because sometimes you may get an answer that might repeat twice. But you could kind of go through the list and keep checking. Then you go check the 2s and the 3s and the 6s and kind of go from there. So that's one option you could do. But usually the better thing to do is once you're here is basically, and again, what we just said yesterday was this expression would be 2x squared minus 1x minus 6. Is we want to check and see, does this thing factor? All right, and to do that, now if it was just x squared minus x minus 6, we just need to find the factors of negative 6 that would equal negative 1. But because of the 2, we've got to do the AC method, so we got to multiply 2 times negative 6 to get negative 12. And we're doing the factors of negative 12, where the sum is going to equal negative 1. All right, now it's not going to be 112, but we can use that to get our signs correct because the B term is negative, so that's got to go with the bigger number. And if you divide two negatives, that makes the other number a positive. So no, the small number is going to, so if we do 2 times 6, it's going to be there and there. If we do 3 times 4, it's going to be like that. All right, and we do have a pair that adds up to -1. That's going to be the 3 and the 4. Okay, so we've got x plus 3, x minus 4. And remember, because we multiplied by 2 in the beginning back here, got to go back and divide by 2. Okay, so this one's going to stay x plus 3 over 2 because that won't simplify. This one, if you do 4 divided by 2, that will simplify. You get x minus 2. All right, now here's where we were talking about last time, that because we're solving these, you can do bottoms up on this one. But remember, if we're going to solve this thing, you really don't have to do bottoms up because we're just going to set this equal to 0. And by setting that equal to 0, we're just going to wind up changing that sign when we subtract it over. So that's going to be -3 over 2. This one, we would do the same thing. Now we're going to add 2 back over. So then there's our other answer. Okay, so then our 3 solutions were -1, +2, and then -3 over 2. And the order does not matter. As long as you've got those 3 answers, any answer order would be okay. And remember that what we said was that whatever power you start with, we started with x to the third back up here, that's telling us how many answers we're looking for. So there's our 3 answers that we were looking for. Okay, so that's kind of what we're wanting to do in this case. It's basically, and again, the first answer is just guess and check. This is one of those where you just have to get lucky, and eventually you'll find one of these that will equal 0. And somebody says, well, yes, there will always be one that will equal 0, no matter what, because you have to have something to start with. It's just a matter of getting lucky and trying to find the right one that's going to go from there. All right, let's give you another one. So we'll do a couple more of these just to make sure we got some practice with it. And that may be it for today. So 2x to the third minus 3x squared minus 8x plus 12 equals 0. All right, again, if we go P over Q, that's the factors of 12 over the factors of 2. All right, now, and again, if you're kind of saying, well, what if I don't remember all that? Some people tell me that they're good about writing numbers in pairs because that way they don't skip something. All right, well, if you want to do that, that's fine. If you want to do 1 times 12 and put them together, then do 2 times 6, then do 3 times 4, so that way you're not trying to cram things in. Hopefully you won't miss anything along the line. It's okay if you do it that way. We'll put it together when we come back and kind of put them in order down here. Okay, so dividing everything by 1, again, doesn't change these numbers, and this is where we'll go back and put them in order here. So we've got 1, 2, 3, 4, 6, and 12. All right, divide everything by 2. That's 1/2. 12 divided by 2 is 6, so that one's good here. 2 divided by 2 is 1, so that one's good here. 6 divided by 2 is 3, so that one's good. 3 divided by 2 is a fraction, so that's going to stay 3 over 2. And then 4 divided by 2 is 2, so that one's good there. So that would be our list of possible solutions that we're looking for. All right, so here's what we're going to do. And I'm going to kind of throw this out here, and I'm going to pause the video while we're kind of going through this one and see what we can do. I'm going to check +1. So we're going to pretend like we're partners here for this one. So I'm going to check +1. And while I'm checking +1, I want y'all to check -1, and that way we can kind of speed through the process and kind of cut some of these down. So I'm going to do the +1. Y'all take a second and check -1, and then we'll kind of compare answers and see what we got, and then we'll go from there. All right. So I checked +1, and +1 did not work. Okay, the -1 worked. I got some shakes. -1 didn't work. Okay, so -1 didn't work. You know, if you go back and just so we can double check it here real quick. Again, you don't have to write this down, but just want to show you that it didn't work. Pull down the first number. That's -2. That's -5. That's +5. That's -3. 3. That's 15. So definitely didn't work. Okay, so that one's out. Okay, so once we've checked off the ones don't work. So now we're going to go check 2s. And it doesn't matter whether you check +2 or -2. Let's just check -2. I don't know. Just to try something different. Okay, so we're 2, -3, -8, +12. All right, -2 times 2 is -4. That's not looking good because that's already kind of a bigger number, -7. If we do -2 times -7, that's a +14. Well, that's not looking too bad here. 14 minus 8 is 6. Okay, that's going to work because -2 times 6 is -12. That's 0. That's what we wanted right there. Okay, so we've got our first solution. So x equals -2. That's the first solution that we're looking for. All right, now, and again, there's probably a 75%, 80% chance that when you get here, now, again, you could keep going through and doing syntactic division. We could check -2 and then check, you know, and you can keep going down the list. We can check the negative or +2 and then plus and minus 3 and then 4 and 6 and 12 and then just keep going down the list on this one. But there's a really good chance that when you get here, that this thing is going to factor. Probably about an 80% chance that this thing's going to factor. Now, and again, this one's kind of similar to the last one, that we're going to have to do 2 times 6, which will be a +12. And we're looking for the factors of +12, where the sum is going to equal -7. All right, B term is negative, so that's got to go with a bigger number. And if we divide a positive and a negative, that makes the other number a negative. Okay, so to get -7, that's the 3 and the 4. Now, again, if you get here and this doesn't work, then you just got to go back and keep doing synthetic division. But again, there's a really good chance that when you get here, this thing is going to factor. So we've got 3 and 4, both of them negative. We're going to divide them both by 2 because we multiply by 2 in the beginning. All right, and this part of it looks kind of similar to what we're doing on the last question. You've got x minus 3 over 2, and that would be x minus 2. And again, but if we're going to do factoring, we'd go ahead and do the bottoms up on this one. But because we're solving it, just set both of those equal to 0. Oh, x minus 2 equal to 0. And to solve this one, we're just going to add 3 over 2 to both sides. Solve this one, we're going to add 2 to both sides. So there was our first answer, there's our second answer, and there's our third answer. So we would have had to wind up using a fraction on this one. So from that list, we had 3 over 2 would have checked out and worked there. Okay, so, you know, that's what you have to, and again, it's just guess and check. You never really know. And tomorrow we'll look at some things that will kind of help narrow some choices down. But honestly, on these, you don't really know until you just start guessing and checking. I mean, there's not really a way to get the first answer. You can narrow some things down using some things that we'll show you tomorrow, but this is really it's just guess and check. You just have to kind of guess and hope one works. And, you know, if it doesn't, then you just go back and check on another one. If we could do partner work and put y'all in some partners and groups and do stuff, this would be great because, again, it would narrow down the choices. But since it's online, adjust it and make it so it's not too bad. So you don't have to do a bunch of these, because if you have to do a lot of these, it's going to take a while. All right, one last problem, and I'm going to show you this one because it's got a little bit of a twist to it. So we got x to the fourth minus x to the third minus 5x squared minus x minus 6 equals 0. All right, it's 5 terms. We don't have anything on the list to do 5 terms. We have 2 terms and 4 terms and 3 terms. So, from our factoring list, this is off the charts because it's 5 terms. We don't have anything for this. The one thing we do know is it starts off with x to the fourth. So we know we're looking for 4 answers. So we've got 4 answers we've got to pick up on this thing. All right, we're going to go ahead and do P over Q, which for this one won't be too bad, because P is -6 and Q is 1. So it's the factors of 6. That's 1 times 6, or 2 times 3. And that's over 1. And the good news is if it's over 1, then there's all your possible answers right there. Because if you divide everything by 1, it doesn't change anything. So it's just 1, 2, 3, or 6. No fractions. And people go, yay, it's no fractions. So no fractions on this one we have to worry about. We only have 1, 2, 3, or 6. Okay, so somebody give me a guess. What do you think? +1 or -1? Which one we want to do first? Or you want to step out of lane and go to 2 or 3 or 6 or something? Because there's not that many for this one. So what do y'all think? Anybody feel lucky today? Anybody throw out a number? Anybody? No? +1 maybe? Sure. All right, we'll go +1. Nobody feels like talking today, so yeah, whatever. Okay. All right, so we've got 1x to the fourth. We've got a -1x to the third. -5x squared, -1x, and then the -6. All right, pulling the first number down. We've got 1 times 1, which is 1. -1 plus 1 is 0. 1 times 0 is 0. -5 plus 0 is -5. 1 times -5 is -6. -6 there, and we're close, but not quite, because 1 times -6 is -6, so that would make a -12. All right, so that one was close. If that had been a +6 there, we'd have been in business, but that one was not a +6, so +1's out, so that's not going to work. All right, so +1 doesn't work. We'll check on -1. So we got 1, -1, -5, -1, -6. First number down to get us going, and then we get rolling from there. Okay, so -1 times 1 is -1. Now we've got -2. Negative times negative is a +2. -5 plus 2 is a -3. -1 times -3 is a +3. 3 minus 1 is a +2. And this one's also not going to work because that's -1. Okay. So neither one of the ones work. +1 doesn't work. -1 doesn't work. Okay, so we'll go to the next one. +2 or -2? What you think? Anybody feeling lucky about those? All right, let's check -2. Let's see what happens. We got 1, -1, -5, -1, -6. First number down. -2 times 1 is -2. -1, -2 is -3. -2 times -3 is a +6. 6 minus 5 is 1. -2 times 1 is -2. -1, -2 is -3. Negative times negative. Now we're getting a +6, so then we're good to go. All right, so we got our first solution at -2. All right, so 1 down, 3 to go. Because we said we had to have 4 answers. There's our first one. And we can go from there. Now, again, we can keep going down the list, and now we can take, because here's options that you could do for these. You could take these numbers that you have here, the 1, the -3, the 1, and 3, these numbers that's left over. And you can go back and start checking 2 and see if that's going to work. And then if that doesn't work, then we'll go back and check 3. If that didn't work, you check -3. So you can keep doing that and hoping that you get some answers. But again, there's a really, really, really good chance that when you get here, this thing's going to factor. So that's x to the third minus 3x squared plus 1x minus 3. Okay, now if it doesn't factor, then we go back and do synthetic division and we start checking everything from there. But again, we're going to hope that this thing will factor. It's 4 terms, so we're going to do factor by grouping. So we'll group the first 2 together, group the last 2 together, and then let's see what happens. Again, we're always going to put a plus sign in the middle, and then we'll still take this +1 that goes with the x and put it on the inside. All right, now, everybody kind of watch this one because I don't think we've done one. Maybe we've done one like this, maybe not. But anyway, we'll see. Here we've got x squared that we can take out. So they leave us with an x minus 3. And then we've got x minus 3 here. We've already got an x minus 3 here, right? I mean, because we've got 1x, so that's really the same thing. If these things are already the same, the only thing you can take out of this one will just be a 1. So if you factor this one off and this is already the same thing here, then basically you just say, all right, the only thing I can do in this, I'm just going to take out the 1 that would be there. I can factor out a +1. All right, so now if we put those 2 together, put our greatest common factors together in here, and then the x minus 3 will go behind it. All right, this one really easy because that's x minus 3 equal to 0. This one we get x squared plus 1 equal to 0. Okay, add 3 to both sides. This one, nice and easy. So we had back up here at the top, we had x equals -2. So we've got that one. Now we've got x equals 3. Okay, we've got x squared plus 1 is equal to 0. And we said the easy thing to do is if, and I think this is what we talked about yesterday. I think we came back and reviewed that one a little bit. That if you've got x squared and a number, the easiest thing to do is just to move that number over to the other side. And then to get x squared down to x, we just have to square root it. So we get x would equal plus or minus. Square root of 1 would be 1. But because it's a negative inside the square root, we've got to add in the I variable. Yeah. Now, if it's 1i, you don't have to necessarily put the 1. So then the last answer we got for this one would be x would equal plus or minus I. So there's 1, 2, and then the plus or minus, there's your 3, 4 answers that we're looking for. Now, somebody's saying, well, wait a minute. They're like, but hey, this plus or minus I wasn't on our list back here, right? They're like, where did that come from? Well, these are all the possible real number answers that we're going to get. Occasionally, there's going to be some imaginary answers, or there might possibly be a square root answer in there. That won't happen until you won't catch that until you get to the end and you start factoring this thing out. So, all that this does back here when we're checking out to find these, this is giving us something to start with so that eventually we can get back to getting all the answers that's here. You're not going to get imaginary answers every time. They're going to pop up every now and again. So don't think you're going to get an imaginary answer with every problem that you do, because you won't. You'll probably get it maybe once every 3 or 4 problems. You'll see some imaginary answers that pop in there. So it works its way out when you get down here and you start factoring and solving and doing some stuff at the end of it. So most of the time that's going to come out when you factor those problems and get what you need to do. So don't worry about those imaginary answers. They kind of just work themselves out when you start solving back here, and you'll just kind of see it. Because if this had been x squared minus 1, then this would have just been regular plus and minus 1. We hadn't to worry about the I. but because the way that one factored off, then we had to put the imaginary part of it in there.